Hi guys, I'm the mathematician. Welcome to topic 8, finding the derivative of a function, finding the min and max, the local min and max, the inflection points, increasing and decreasing intervals, and concave up and concave down.
Hello class, today I'll be giving you an overview on f of x, and when the function is increasing, decreasing, a min or a max, concave up, concave down, or inflection point. First let's look at decreasing. The function is decreasing when f prime of x is less than 0, and it's increasing when it's more than 0. Also, a min and max occurs when f prime of x equals 0. And also we'll be testing a given interval. The function is concave up when f double prime of x is greater than 0, and f double prime of x is concave down when it's less than 0. Also, there are inflection points where f double prime of x equals 0.
Let's start visually. Here's a graph of f of x equals sine x with an interval from 0 to 2 pi. We need to find the max, min, inflection points, and concavities of the derivative of f of x. Let's use what we know about this equation. F of x has a max at pi over 2, 1, and a min at 3 pi over 2, negative 1. F of x has an inflection point at 0, 0, pi 0, and 2 pi 0. F of x is concave down at 0 pi and concave up at pi over 2 pi to 2 pi. F of x is increasing at 0 to pi over 2, union 3 pi over 2 to 2 pi. F of x is decreasing at pi over 2 to 3 pi over 2. Now let's look at the derivative of sine of x. Cosine x. From the graph, we can see that f prime x has a max at 0, 1, and at 2 pi 1, and a min at pi negative 1. The inflection points are at pi over 2 and 3 pi over 2. It's concave up from pi over 2 to 3 pi over 2, and concave down from 0 to pi over 2, union 3 pi over 2 to 2 pi. Can you see the pattern? It's like magic! F of x has a max and min, where f prime x has a 0. You know it's a max or min graphically because if f prime x changes sign from negative to positive, it's a max, and if it changes sign from positive to negative, it's a min. The inflection points of f of x are the mins and maxes of f prime x, and when fx is concave up, f prime is increasing. When f of x is concave down, f prime is decreasing. Now let's move on to the second derivative! Now, to find the second derivative, you're pretty much just taking the derivative of the first derivative. The same rules apply. For this specific graph, the derivative of sine of x ends up being cosine x, and the second derivative of sine x ends up being negative sine x.
Plug the values into the second derivative, and if the second derivative was negative, that meant it was a max, and if it was positive, it meant it was a min, because a minimum is concave down, or concave up, meaning that it goes from decreasing to increasing, and a maximum is concave up, meaning it goes from positive to negative, or it goes from increasing to decreasing. Next, the interval values of negative 2 and 2 were plugged in. So once these values were plugged into f of x, it was found that the minimum is negative 2, and the maximum is 2, 10. So the local minimums were the values which were the zeros of f prime of x, and then the absolute minimums and maximums were the values of the interval. Next we'll find where the values are increasing and decreasing. In order to do this, we'll use the mins and maxes found here, and also the values we found in the intervals negative 2 to 2, which were the absolute minimums and maximums. So in order to do this, I, Mr. Puppet, set up a timeline which shows from negative 2 to 2, and these are the values in between, which were the zeros. So from negative 2 to negative 1, it's positive when plugged into f of x, and from negative 1 to 1/3, the values are negative, and from 1/3 to 2, the values are also positive. So this means that the equation is increasing from negative 2, negative 1, union 1/3 to 2, and it's decreasing from negative 1 to 1/3.
Ta-da! Now, we'll finish up this with inflection points and concave up and concave down. So, as we learned before, we find the inflection points by plugging in a 0 for the second derivative. So what we did here, we equaled the second derivative to 0, and we got x is equal to negative 1/3. So now we know that the inflection point for f of x is at x equals negative 1/3. Now, to find concave up, we have to take the second derivative, and for it to be concave up, we have to make sure that it's greater than 0. So we found that x is greater than negative 1/3. The next step is to plot it on a graph. So we find that on this graph, and we have the interval from negative 2 to 2, and we have negative 1/3. So from this, we know that negative 1/3 and onward, it's positive, but then that means that the rest of it is negative. So we know that f of x is concave down from negative 2 to 1/3, and concave up from negative 1/3 to positive 2. So, and this is how we know that where it's concave up and concave down.
Now that you know how to find the mins, maxes, concave up, concave down, and inflection points of a derivative of function, you too can be a math magician.